These are the notes for Unit 7, Day 1. They start on page 3 of your packet. We're going to start off this unit looking at something called a differential equation. And so the essential question is, what are differential equations? And what we're going to focus on is modeling situations and verifying solutions of differential equations. So a differential equation, quite simply, is an equation that involves x, y, and y prime. Or maybe a little more generally, it involves an independent variable, a dependent variable, and a derivative of that dependent variable. The general form is dy dx equals some sort of function in terms of x and y. So quite literally, a differential equation is a derivative. Now, in order to talk about differential equations, we need to remind ourselves what direct and inverse variation mean. So remember that direct variation means that y varies directly with x, or in other words, the dependent variable varies directly with the independent variable. Or another way we can say that is y is directly proportional to x. And mathematically, it looks like this. So when x goes up, y goes up by a factor of k. And then in inverse variation is y varies inversely with x. Another way of saying that is y is inversely proportional to x, and that is this relationship here. So where when x goes up, y goes down. So those two variations, we just have to remember those. We learned those in an earlier class. Okay, so let's take a look at some examples here. We're writing differential equations. In other words, we're looking at what we have, and we need to find the relationship and write that expression. So here's what we have here. We have a rumor that spreads among a population of n people. So that's how many people we have. And the rumor is spreading at a rate proportional to the product of the number of people who've heard the rumor and the number of people who have not heard the rumor. Okay, so we've got a population n and a rate that is proportional. So the rate is the dy dx, and it's proportional, so that's k. That's your proportionality constant. And so this rate proportional, this is implying direct proportionality. If it were inverse, they would say inverse, but sometimes they don't use the word direct. So proportional to the product of the number of people who've heard the rumor and the number of people who haven't heard the rumor. So product is multiplying the number of people who have heard the rumor and the number of people who have not heard the rumor. So if you think about that, either you've heard it or you haven't. So this population adds up to n. Okay, and now it's telling us what variables to use. If p denotes the number of people who have heard the rumor, so we're looking at dp dx, or we could call it dt. That's another independent variable. So if p is the number of people who've heard the rumor, then dp dx is the rate, and so that is proportional to the number of people who've heard the rumor. So that's p. And so the number of people who have not heard the rumor is n minus p. Okay, if 10 people hear it and there's 40 people, then 40 minus 10 have not heard the rumor. So it's the number of people who've heard the rumor and the number of people who've not heard the rumor. And it's directly proportional, that's what that means. That's what the rate is. So looking at this and matching it up with one of the options, that looks like option B. And it goes on to say, we should be using with respect to time and k a positive constant. So really, from the question here, this really should be a dt. They've told us it should be. Okay, so verifying solutions. That last example was just really, how do I set up a relationship that's in the form of a differential equation? If you notice, this equation has an independent variable and a dependent variable, the independent variable being n, and the dependent variable being p, and the independent variable being x, and then a derivative here. So notice the derivative dp dx or dp dt, it's the derivative of the independent variable over here. We can verify solutions if we have a differential equation. So verifying solutions in calculus is just like verifying solutions in algebra. we substitute things in for variables, and we see if the algebraic expression holds. Like if you have 2x plus 3 equals y, and you want to know if 0, 0 is a solution, then you would plug in 0, 0 into that equation. That's all we're going to do here. So here's our differential equation. And you have to be careful here because this is where the College Board sneaks in the chain rule. So this is our differential equation. We have a first and a second derivative in this expression. So we call this a second order differential equation because we have a second derivative in the expression. And we also have the function itself. So what they're really asking us to do in this question is solve these three problems. Use this as y and plug in y here and its derivative and its second derivative, see if it all equals 0. And then do the same thing for this. And then do the same thing for the general expression for number 2. And I say it's a general expression because instead of a 3, there's a c here. We've changed the power. So it's kind of like representing a family of functions that look like e to the 4x. And so if you notice, we have a chain rule in each one of these. So this is really where College Board tests your chain rule. Okay, so let's look at the first option. So we know y equals 2 sine x. We need y prime. So we're going to do a chain rule here. This is going to be 2 cosine 4x times 4. And so the 2 times 4 with the chain rule is 8. So there's your first derivative. And then your second derivative is differentiating this. So you're going to have a minus 32 because of the chain rule, and then sine 4x. So now we're going to take these and substitute them into here. So we're going to have minus 32, that's y double prime, minus 6 times y prime, so 6 times this, and then plus 8 times y, so 8 times this. And then we want to see if that equals 0. So I put a question mark there. Okay, so doing the math here, right, we can see that we have, a combination of sines and cosines. There's no possible way we're going to be able to make that equal to 0, right? We might be able to get 32 sine 4x and negative, and that positive 16 sine 4x. So the sines don't even go away, and there's no way for the cosine to go away. So without even doing any additional math, we know that that's not going to be a solution to the differential equation. So we know 1 is out. So that means A is out. And that's the only one we can eliminate right now. Okay, so let's look at 2. So we repeat the process. We know y is 3e to the 2x. We need y prime. We'll put a chain rule here. So this is going to, the derivative is going to be 3e to the 2x times 2. So I'm going to have 6e to the 2x. And then y double prime, right? E is always the derivative of itself. Y double prime is differentiating this. So it's going to be 6e to the 2x times 2 again. So it's going to be 12e to the 2x. And now I'm going to put all of this into there. So I got 12e to the 2x minus 6 times this plus 8 times this. And if you notice with these functions, because it's not a trig, we're not going to have that switching from sine to cosine. So this could possibly be equal to 0. Let's see what we have here. We've got 12 minus 36 plus 24. So that definitely 12 minus 36 plus 24. So think about 12 plus 24 is 36 minus 36. So that does equal 0. So we know that's a possibility. So now we know B and D are definitely yes. So now we got to check out option 3. So 3 is the generic equivalent of what we just got done doing. So differentiating this is going to be CE to the 4x times 4, or 4CE to the 4x. Y double prime is going to be 4CE to the 4x times 4 again. So that's going to be 16CE to the 4x. So let's see if this works for any value. That's basically what we're saying. Let's see if this works for any value C, or does it just work for 3? So substituting that into the differential equation, we get y double prime minus 6 times y prime plus 8 times y. And does that equal 0? So let's take a look at the coefficients here. Everything's e to the 4x. We got 16c minus 24c plus 8c. So again, we got 16c plus 8c is a plus 24 minus 24. So this definitely equals 0. And so we know 2 and 3 work. In other words, CE to the power 4x, any value C will work. If it was a 3, if it was a 10, if it was a pi, any value would work. In fact, if we go and we look at the power, actually any power would work as well. So we know this answer is D. So that's how you verify solutions. We did a trig and we did 2 exponential examples, kind of all in that one question. All right, so you try this one, turn off the video, try this one. This is similar to question 1, writing the differential equation based on the problem. Okay, if you're tuning back in, I'm assuming you've given this a try on your own. So it says we have the weight of the population of yeast is given by differentiable function. Okay, where W of T is measured in grams and T is measured of hours. So by the variables, we know we want a dW dt. The weight of yeast increases with respect to T at a rate that is directly proportional to the weight. So dW dt is K times W. That's what that's saying. Okay, so we know we have this much. So we know we can eliminate A. A is not a differential equation. It says at time T equals 10, the weight of the yeast is 200 grams. This is going to help us find K, because if you notice, we don't have K in any of the answers, the variable, the constant K. We have actually a numeric value, so we got to find it. So right now we know that it's either C or D, because it's not directly proportional to the time, it's directly proportional to the weight. So we know we're picking between these 2 options. Okay, so let's put in the numbers and see if we have half or 1/40th. So we are going to find that K. So we know that the dW dt, it's increasing at a rate of 5 grams per hour. So this is positive 5. But we're decreasing, it'd be negative 5. And that's at time 10 hours, the weight of yeast is 200 grams. So W is 200 grams. So we're solving for K here. And just by inspection, without doing any math, we know that K is not going to be a half. We know this is not true. It's got to be C. So we know K is 5 over 200. That's not a half. I'm sure it is 1/40th when we reduce it. So we're going to eliminate D. We know the answer is C. So the differential equation is going to like dW dt equals K, which is 5 over 200 times W, or 1/40th. Okay, try this one on your own. It's again forming another differential expression or differential equation. Okay, so if you're tuning back in, you've attempted this on your own. We know that we have linear growth. So it says if P of T is the size of a population at time T, which of the following differential equations describes linear growth? So we know that the function is linear. So think about that. If the function is linear, then what is true about its derivative? Okay. So if the function is a linear function, if we differentiate a linear function, right, a linear function is constant slope, so it must have a constant derivative, because when I say slope, you're thinking derivative. So we must have a constant derivative. So we have a constant differential equation. So which one of these expressions is dp dt equals a constant value? And that's A. 200 is a constant value. 200 is never going to change. B is going to change depending upon T, so is C. D is going to change depending upon P, and so is E. So the answer here has got to be A. All right, so try number 5 on your own. This is asking you to verify. We have a function y equals k sine 5x plus 2 cosine 4x, and we want it to be a solution of this differential equation. So we want to know what value of k will make it a solution. So when we look at the differential equation, we need y, that's this, and we also need y double prime. So, and again, do you see the chain rule in here? So kind of keep that in mind. And why don't you go ahead and pause the video and try differentiating this twice, substituting it into here and finding k. All right, so if you're tuning in, let's go through the steps to accomplish what I just said. So we need to do the substitution. We needed y and y double prime. Well, we know y, it was given to us. The only way to find y double prime is to find y prime first. So let's differentiate this, use our chain rule. So when we differentiate this, we're going to get k cosine 5x times 5. In other words, 5k cosine 5x. And when we differentiate this, we're going to get negative 2 sine 4x times 4. So negative 2 times 4 is negative 8 sine 4x. And now we need to differentiate again. So another chain rule again. The derivative of this is going to be negative 5k sine 5x times 5. So negative 5k times 5 is negative 25k sine 5x. And then differentiating this is going to be negative 8 cosine 4x times 4. So negative 8 times 4 is negative 32 cosine 4x. So we're going to take this bottom expression and this top expression and put them into this, put them into this differential equation. I was pointing out the wrong one. And we're going to solve for k. So let's go ahead. We know we have this differential expression. And so I need 16y. So 16y, I'm taking this and multiplying it by 16. 16y is 16 of these and 32 of these, right? I'm just multiplying through by 16. So I know I have that for 16y. And then y double prime is just this. So I'm going to rewrite it over here. So I'm going to add these two things together. I'm going to add them vertically here. So I'm going to add those things vertically because they're nice and aligned here like terms are. So this is the sine term. And so this plus this is going to be negative 9k sine 5x. And then this plus this is 0. So when I take y double prime plus 16y, that's everything here, y double prime plus 16y, I get negative 9k sine 5x. And so that's going to be equal to negative 27 sine 5x. The sine 5x's are going to cancel. And I'm going to get negative 9k is equal to negative 27. And when I divide by the negative 9, I get k equals 3. So the answer here is C. K equals 3. So that's a little bit of a different spin on it. You're not really verifying it. You're just saying what function do I specifically need. I want to get the k out of there and put a specific number in there so that this whole thing works out. Okay, so when we get back into the classroom, we'll go through the takeaways and we'll work on our topic questions.